All right, let's take a look at this. It says, how can we arrange these tiles? Okay, so can we all agree that we have an x squared inside of the box? We also have 6 x's that I've lined up, and 5 1s, totaling 5. But when we use algebra tiles, we would normally take an x times x makes x squared, x times 1 makes x, right? We would do this all the way down here. But I've got 5 just sitting over here, not lined up in a nice, neat rectangle. So what could I do with these 5 1s? I could grab them, bring them over here, but then I still have 1 left over. I can't do that, right? Anybody have an idea? Come on, go. Well, I can't. Everything just like a multiplication chart. 2 times 3 makes 6, right? So I can't put them in out here on the outside of the box because those are my factors. X times x makes x squared. This is the solution in here. I could technically cancel. I don't need to though. Don't think about multiplying yet. Think about how we could arrange these 1s. Yeah. I could put a 1 underneath all the x's. Good job. But then I've got this guy. He's all up by himself. What could I do with this one? Good job, Patrick. Good job. So now I have 1 times x is x. 1 times 1 is 1. Wouldn't I just fill these in? So this is an area model that shows us how if you multiply x plus 1 times the binomial x plus 5, you get x squared plus 6x plus 5. Everybody okay so far? All right, so this is where you're going to take notes. Go ahead and write this down. We're going to take what we just did and put it into the box method. Okay, so let's look at something really quick. Let's go back here. Let me get a line here, something that's a little bit thicker. You guys see that this is really just its own box in here? I have an x squared up here in the corner. I have 5 1s down here in this corner. I have 1x here, and I have 5 x's here. Isn't that the same thing as our box here? I have 1x squared up here. I have 5 over here. What am I going to do to fill these 2 boxes? What number, when I multiply, I get 5, but when I add, I get 6x? 1x, and what else? 5 x's. Isn't 1 times 5, 5, but 5x plus 1x equals 6x? All right, let's factor this. I have an x times an x makes x squared. X times 5 makes 5x. What do I need to multiply by x to get 1x? What number do I multiply by x to get 1x? 1. And 1 times 5 is 5. Does it work? So I have x plus 5 times x plus 1. Isn't that also like doing this? Splitting it 6x into 5x plus 1x? Everybody see that? Last week, didn't we call this factoring by grouping? And you just put, when you have 4 terms like that, you just put them inside the box and factor in. This is the same idea, only you have this term in the middle that you have to guess which 2 numbers you can make it up to make it, when you multiply, you get 5, and when you add, you get 6. That sounds familiar. Does that sound familiar? You've been doing that with those big X's, right? Right? If you have 5 and 6, what two numbers make up 6, but when you multiply them, they're 5? 1 and 5? Not the same thing you've been doing? All right, we're going to do a version of that. There's one more thing I want to show you. I did. 5 times x is 5x. X times 1 is x. When I add those together, I get 6x. You don't have to do this every time. I'm just trying to show you every single way these things relate. Moving on. All right, let's look at this one. Your turn. They're already in a rectangle. Let's distribute these. Where could I put these? Now what? Put them all underneath? Now what? Good, you guys got it now, right? Move that one over there. We have it factored. So x times x makes x squared. 1 times x makes x, and each one of these is a single digit. So what are my two binomials? X plus 1, x plus 6. And what are going to be, what am I going to put in that box on the next page? Can you see it? Is this helping? You're supposed to be a little bit confused. Yeah? Does that help at all? Take all that away. Now do you see it? Better? Alright, so let's arrange it. Look how cute. I heart factoring. I wish I had a button like that. What? You think so? Okay, so what do I put in these two boxes? How did I break up 7x? 6x and x. You guys are catching on very quickly. X times what makes 6x? 6. And what times x makes x? 1. X plus 1, x plus 6. I'm going to do my little rainbow method down here. That's 1x. That's 6x. That totals 7x. This is how I always double check, and that's exactly what I have up there, 7x. Questions by anybody? Pretty easy so far? This one's a little bit more challenging. I'm going to let you look at it for a second. Okay, what do you think we do? You want to rotate one of the negative x's. Okay, and like this. But then what? There's no room for them. You can't. That doesn't work. On this side? Over here? They don't line up there. Yeah, but they don't line up. Any other ideas? Okay. The x back, all right. I'll tell you that's a hint. Connor? You can't do this. You're talking about this? You can't, this has to be in the same shape. The only thing that fits here is either an x or a negative x. Don't need to. Think of what I could add to this model. Okay, can I just add a positive x? That I can just add that to it? Yes. Oh, I see what you're saying with that, but can't do that. But am I just allowed to just like throw an x over here? Add one what? A what? A positive one? I can add an x and a positive one and that works? We don't have another side. We don't have any, there's no equal sign. You can't just you can't just put one. I'm not going to press pause. I want you guys to figure this out. How you guys are on the right track. I can add an x, but I can't just add an x. Wait, what? Can I add that? But watch. Does that make sense? This is why you can say negative 3x plus x makes negative 2x. Right? And the only reason I could add it was because I was really only adding nothing, because a negative x plus an x is 0. So am I allowed to add nothing to it and it's still the same? Yes. They're placeholders. So what are my two binomials? Can you do it without me doing the outside? X and an x, and what else? Plus 1 and what? Minus 3. Good job. X times x. 1 times x makes a positive x. And these are all negative. Does your brain hurt a little bit? Just a little bit? It's supposed to. It's supposed to make you go, that's interesting. I never saw it that way before. So if I were to take a big X, my box, and organize these, how would that look on this page right here? What do I write here? X squared. What do I write here? Negative 3. What two numbers, when I add them, I get negative 2, but when I multiply, I get negative 3. Negative 3 and 1. Good job. X minus 3, x plus 1. Negative 3x positive x makes negative 2x, which works. Any questions? All right. I want you to, if you are an A, I want you to raise your hand. A's are on this side. Michael, raise your hand. If you're an A, raise your hand. Connor, drop your pencil. You're not going to be writing. You're going to explain to the person next to you how to do number 4. When you're done, we're going to switch. I'm going to walk around and make sure that you guys are talking. I have a hint. Check this out. If you get confused or stuck, what would go on top? And what would go on the bottom? Now, don't get confused. This is going to change later, but this is just a model to look at now. And think of the two numbers that would go in there. When you multiply, you get 8. When you add, you get 6. Okay, forget that I did that.
Why?
Okay, so Andrew has volunteered to stage for me. Okay, Andrew, tell me how to do number 4.
Alright, you put X in the first box.
Thank you.
And so put X on the left of that box and on top of it. And
X goes here?
huh? No.
Okay.
So outside of it.
Outside of it?
Yeah.
Here?
Yeah, and on top.
Okay.
That's when you get X squared.
Okay.
And then basically the two things are X plus 2 and X plus 4.
X plus 2 and X plus 4?
It's about 2, what do we call it? What do you call this?
Terms?
No.
Variables?
Oh, you know how you get like X plus 2 and X plus 4. Those are the two things you get.
Oh, down here.
Yeah.
Okay, where'd you get that from?
Because I put 2 and 4 together.
You put a 2 and a 4 in here? It's hard to explain things, isn't it? That's why we need to practice.
Oh, explain.
It works a different part of your brain.
So, on the left side,
Mm-hmm.
on the outside, okay.
Oh,
And
okay.
on the top, outside, 4.
Okay.
And so you get 2X.
So what goes inside of
4X.
here then?
2X and 4X, so that's we get the 6X, and maybe 2 and 4 is 8, and those are,
Good.
yeah.
Everybody agree? Elgin, you want to do number 5?
Yeah.
X squared, and then on the top, inside,
Top left corner here. Why don't we stop jumping ahead of ourselves and just fill the box in first?
okay. So, you get 16.
Where's 16 go?
Why will X on top?
Over here?
No, all the way on the right. Like a big X. No. You need to multiply. Yeah.
Okay.
So it's 16 outside. And then it's on the bottom. So you get that. Why don't we just say it in the bottom?
Keep going. Let him keep going. He's working it out. You use the factors of -8 and -2, and this is the way you got those numbers. Okay? That's fair enough. Put -8 here. Good. What goes here? Good job. So we don't need this. Yes. Yes. Not these problems. Keep going. Good job. Okay. What goes here? Good. So the factor of -2x and 16 is -2. Let's make sure it works. X times x is x squared. X times -8 is -8x. -2 times x is -2x, and -2 times -8 is +16. Good job, Elgin. How did we do today? What do you think? Rate it.
4.
Got a 4? Good job.